watching a lesson on implementing local storage. Okay, so to get things started, what we're looking at right here is NYMem1. This is a member server in the Global Mantics domain. I will tell you that if you want to follow along with what we're doing here, you don't have to be on a Global Mantics server called NYMem1. You could be on pretty much any Windows Server 2012 computer. This just happens to be the one that I've selected. And the reason is because I decided I'd rather play around with the disk configuration of this member server than I would with one of our domain controllers that we've created for this particular network. So the first thing I want to do is I want to just kind of take us right over into disk management. And we do this through a utility called computer management. So I'm going to hit start on my keyboard, which brings me over into the start screen. And I'm going to type in computer, and really I can stop right there and you'll notice it says computer management. So I'm going to click on computer management. And let me go ahead and maximize this. All right, so in computer management, if you come down through here, you'll see that we have disk management. And if I click on disk management, it will then show me how my local storage has been configured. Up at the top, you'll see the different volumes that we have. Okay, so you'll notice that I have what here? I have my C volume, right? That's my C drive. And the volume, just to be clear, the volume is a logical representation of storage space on a physical disk. And we'll look at the physical disk in just a moment. The second thing I have here is my DVD drive. Okay, so that's my D drive. And my last volume here is a system reserved volume. This is something that happens when you install the Windows Server operating system the way we did, which is where we just look at the hard drive as a whole, right? We looked at it as just one solid, unallocated chunk of space. And I told it to just install the operating system. What it does is it goes ahead and it creates this real small system volume. And so that's why we see that volume here. Now, if we look down in the bottom section here, you'll see that there are two physical disks. Okay, and if you look real carefully, you'll notice there's really only one physical disk when it comes to hard disk space. And the reason is because we have disk 0. Okay, this is the one disk all the way across here. That's one disk. And the other one is it says here CD-ROM 0. And even though it says CD, it is actually a DVD-ROM. You can notice it says DVD right underneath. Okay, so you'll notice that we have our hard disk up here. We're just going to ignore everything from here on forward as far as the CD, DVD drive. I just wanted to make sure you understand what you're looking at. Now, as far as disk 0, and that's how these disks are ordered, by the way. The first one will be called disk 0. The second would be disk 1, the third disk 2, and so on and so forth. You may recall, if we go all the way back to the very first lesson where we installed the Windows Server operating system, I set up my virtual machines here with a single 200 gigabyte hard drive. And that's what we're seeing here, a single 200 gigabyte hard drive. And you can see that this hard drive has been partitioned. Yeah, that's an old term that we used to use. We used to call these things partitions. Well, we still use the term partitioning, even though we're now calling them volumes. Okay, we don't call them voluming. I don't even know how that word would be said. So these partitions that we have here, or this disk that we have here, has been partitioned into these two volumes. We have that system reserved volume. We see that here. And then we have our C volume, which we have here. Okay, so not only do we see our volumes up top, but we also see a physical representation of these volumes here. You'll notice that this entire physical disk, this entire 200 gigs of hard drive space, are used. If we wanted to change that, there is a really cool feature built right into Windows Server 2012, which is where we have the ability to either grow or shrink a volume on the fly. So if I took my C drive, right, take this volume right here, which is currently just about the entire 200 gig, and if I thought to myself, man, I didn't really want to do that. I was thinking maybe I'd only do 100 gig for the C drive, and I'd leave the other 100 gig for another volume that would be used for other purposes. I can right-click on this volume right here, and I can choose to shrink that volume. Now you'll notice I also have this thing that says extend volume, but it's grayed out. Can't extend a volume that's, well, there's no more space to extend it to. But I can shrink the volume. So I'm going to click on that. And what it's doing is it's going through and querying, well, how much available shrink space there is. So what it's doing is it's looking to see how much of this volume is actually used and what's on this volume. And therefore, how much can we shrink it and still be safe from corrupting everything? And you'll see here that the total size before we shrink is 204,447 megabytes, or basically just under 200 gig. And then the available shrink space is 192,284 megabytes. Okay, so that's how much space we could shrink. And if we chose to shrink that entire amount, look what we'd be left with. About a 12 gig hard drive. That's all that's being used. All right, so how about we take this, and just for nice round numbers, I'm going to say 100,000. We're going to take 100,000 of the megabytes that are in this particular volume. We're going to get rid of them. We're going to say it's no longer going to be part of this volume. And I'll go ahead and, by the way, it tells me right here, I'm still going to be left with about 100 gig, and that's what we want. So I'm going to click on shrink. And it takes just a moment, and you'll notice it's fairly quick. Matter of fact, it's already done. And you'll notice that I now have, well, it's actually 102 gig. That's fine. We're just trying to be approximate here. And then I have almost 100 gig of what's now called unallocated space. With that unallocated space, I could right-click on it, and I could create a new volume. And you'll notice there's a number of choices here. We have a simple volume, a spanned volume, a striped volume, a mirrored volume, and a RAID 5 volume. Now, these are not new to Windows Server 2012. Matter of fact, they're not even new to, oh man, we'd have to go all the way back to like Windows NT. And this stuff has always existed. Spanned volume actually came along, if I remember correctly, I want to say it was with Windows Server 2003, but that wasn't always there. But everything else has been around since, well, pretty much as far back as Windows Server has been around. A simple volume is just what it sounds like. It means I'm just going to create a volume, right? And I'm just going to take an area of this space and I'm going to turn it into a logical volume. So let's do that. I'm going to click on the new simple volume. I get a little wizard where I can click on next and then say, all right, of the 100,000 megabytes that are available, how much do we want to make into a new volume? So let's take half of it. I'm going to say 50,000. Click next. I can assign it a drive letter. Okay, and the first available letter is E, but if I pull this down, you'll see I have all kinds of choices. And even though I said the first available choice is E, you'll notice there is a B. It's not good practice to use the letters A or B ever for a hard drive. And the reason is because those were originally reserved exclusively for floppy drives. Now, floppy disk drives haven't existed. I mean, they still technically exist, but they really haven't been used in quite a few years. But it's still good practice to avoid those letters if possible. So if we go ahead and just go ahead and choose the drive letter E, that's fine. Another option we could do is we could do what's called mount this to an empty NTFS folder. This is something that's also been around for a while, but not heavily used. Okay, so I mostly want you just to understand this. Let's say you get a question on the test. You want to know about creating a mount point or mounting to a folder. If I were to create a folder, so I could literally go, let's say, to my C drive, I could create a folder, and as long as that folder is empty, I could mount this new volume to that folder. And so what that means is, on the C drive, if I were to go into that folder that I created, I would actually be going into a whole new 50 gig volume. Now, did that sound confusing to you? Because I'm going to be honest with you. It's confusing to me. And the part that's confusing to me is why. Why you would do this. And this is something we've struggled with over the years. I have talked with many experts, and I've yet to come across a single person who could truly give me a really good reason for doing this. I have heard a regular response of it keeps the Unix administrators happy, because I guess mount points are real common in the Unix environment. The only other explanation that I've been given is it's a great way to emulate that one drive, okay, one volume really I should say, not the physical drive, but one volume is bigger than it really is, right? If my C drive is 100 gig and I have a folder in that C drive and I've mounted an extra 50 gig into that folder, it's almost like I've turned that C drive into a 150 gig folder. So anyway, like I said, don't worry too much about this. I just wanted you to understand what it is. But you probably won't do this on a regular basis. You'll typically be assigning a drive letter. So I'm going to click on Next. Now I get to choose if I want to format the volume. And of course, you have to format it if you want to actually be able to put data on it. And as long as we're here on formatting, it's at this point that I want to mention this right here, REFS, which stands for the Resilient File System. This is brand new to Windows Server 2012. And I'm not going to spend a lot of time going into the inner details of the Resilient File System, but I will tell you that it basically was designed to do was to enhance the capabilities of NTFS. Okay, it was developed in an effort to improve NTFS by offering larger maximum sizes for individual files, directories, disk volumes, and it also gives you, and you could probably guess this because it's right in the title, it gives you greater resiliency, meaning better data verification, error correction, and scalability. Okay, so that's what REFS is. Not going to spend any other time going over it. Just want you to know it's there. So let's go ahead and take NTFS. For the sake of time, let's perform a quick format. Oh, by the way, you could also label this volume if you wanted to give it a name. If you knew that this was going to be a volume specifically for something, you could give it a name so that you would help recognize that. So I'm going to do a quick format, click Next, and Finish. And fairly quickly here, you can see that the volume was created. For a brief moment, I don't know if you caught it. You can always rewind this real quick and see it again if you want to, but it said formatting for just a moment, and now it says healthy. I will also point out that up above, we have new volume, E, and what we have left over here is the remaining approximately 50 gig of unallocated space. Now, if I right-click again, I want to talk to you just real quick here about these spanned, striped, mirrored, and RAID 5 volumes. Again, these are not new, but you need to know what they are if you've never heard of them before. So just real quick here, a spanned volume is where you take an area of disk space from more than one physical disk. Okay, so, and that's why they're grayed out, by the way. Every one of these has to do with using multiple physical disks. And I don't have multiple physical disks here. Okay, I just have the one. If I had multiple disks, I could span the volume by taking an area of space from one disk and an area of space from another disk and having them work together as a single volume. Okay, so it's one single logical area of space. Now, I'm going to tell you that there's nothing special about this spanned volume in the sense that there's no performance benefits. There's nothing special in the way that data is written to or read from this particular disk space. It's basically going to use up however much space is on one disk, and then it's just going to continue on to the next. The only reason for doing it is to allow yourself to have a larger volume than what one physical disk could hold. A striped volume is also known as RAID 0. RAID 0, which is called disk striping, is where you have two or more physical disks. What you do is you take an equal amount of space from each of those two or more disks, and you will now stripe the data across all of the disks. The reason we do this is by spreading the data out, by evenly striping it across all the disks, we get read performance benefits. When we go to read the data back, if you have what's called bus mastering hard disks, which many disks these days are bus mastering, meaning they don't have to take turns. You can actually read and write to multiple disks at the same time. Well, what you can do is you can be reading the data simultaneously from multiple disks. So if the data is spread out, let's say we had 3 disks. If you spread the data out between the 3 disks, you can read theoretically 3 times as fast. Now, the next type of volume here is something called a mirrored volume. And I will tell you that this is also RAID. And when people think of RAID, they think of some form of redundancy or fault tolerance, right? It's right in the name of RAID, right? redundant array of inexpensive disks. Well, RAID 0, which was the stripe volume we were just talking about, does not have any fault tolerance, meaning if something were to fail, you still lose your data. You still go down. But with a mirrored volume, this is our first level where we do have fault tolerance. A mirrored volume is where you take two, and exactly two, so not two or more, but exactly two physical disks. You take an equal amount of space from each, and you make it into one logical volume. But here's what's happening. The data that is written to one is also written to the other. You have an exact mirrored copy of the data. So the data exists in both places. Now the benefit of this is, well, twofold. Number one, you do get an increase in read performance. And the reason why is because the identical information exists on two different disks. So you could actually read half the data from one, half the data from the other. But the main reason that we would use a mirrored volume would be for protecting against the failure of one of those disks. If one disk were to fail, no problem. The other disk still has the information. Your computer's still up and running. Now the last one we have here is what's called a RAID 5 volume. You'll never guess that lines up with RAID 5, which is also known as disk striping with parity. It's where we take a minimum of 3 physical disks, and there can be 3 or more, and we take an equal amount of space from each, make them into one logical volume. But here is one major difference between this and what we did with the stripe volume. In this case, when we're striping the information across all the different disks, one of the disks on each pass-through, in other words, you have a pass-through where you're writing data to all the different disks, will be what's known as a parity piece of information. And it's this parity information that is used to recover the data in the event one of your disks were to fail. So basically, you get the performance benefits of disk striping, but you get the fault tolerance built in as well. Now, the only negative to using a RAID 5 volume is that you do have a bit of a performance hit when it comes to writing the data. So when you're writing the data, because it needs to calculate out and write that parity block, so you're actually writing more data than the actual data itself, and there's different math formulas that are being put into place all at the same time. Well, when you're writing that information, there is a little bit of a performance hit. But the read performance is much faster. Now, here's what I need to tell you, though. And this is why I just kind of talked to you about these real quick here. And we're not going to go through a huge demonstration of adding all these additional disks to the computer so that we can create these volumes. And by the way, I welcome you to do it. And I welcome you to go through and play with each of these and see how they come out. But here's why I'm not overly worried about it. And that is that this is what's known as software RAID. And typically, software RAID is not what is used in the real world. Typically, you would use a hardware RAID configuration where you actually purchase a physical RAID controller who will do these different things on your hard disk for you without having to bother the operating system. Okay, so you're not taking overhead away from the operating system itself. They tend to be much more flexible, much more reliable, and that is truly what would be typically used, would be hardware RAID. Now, one other thing I do want to show you real quick here is I showed you earlier that we could shrink a volume, right? We took that C drive and we shrunk it down. Well, now that we have some free space here, I'm going to right-click on the E drive, and I want to show you that I can also extend the volume. And you can pretty much guess how this is going to work. If I click Next, I can now select where I want to extend it to. Now, this is one thing that's a little bit different than when we shrunk the volume. We can extend it either to the unallocated space here on disk 0, or if we had other physical disks, we could turn this into a spanned volume by extending out onto other physical disks. So this is the disk that has been selected. You'll notice that we have 50,000 available megabytes. And how about we say that we want to use the entire 50, or you know what? Let's do the 25,000, right? Just so you can see the difference so that everything's not used up. So I'm going to say I want to use 25,000. Tells you that we're going to turn into a 75,000 megabyte volume. Click Next and Finish. Takes just a moment. Matter of fact, it's an extremely quick moment. And you'll notice this is almost a 75 gig partition. and we only have about 25 gig of unallocated space. Now, the one last thing that I want to show you before we wrap things up here is I want to bring us all the way back over here to the left side where we see disk 0 here. And I want to point out that it says that this is a basic disk. A basic disk is the type of disk that we have used since, well, pretty much the invention of hard disks. Okay? Basic disks are compatible with DOS. Okay? You can go all the way back to DOS on a basic disk. But we now have some much more flexible capabilities with something called dynamic disks. So if I were to right-click on this disk, you'll see that I could convert to a dynamic disk. Now I'm not going to do it because it would take a couple of reboots, but I could click this and whatever disks that I have here, and notice I only have the one, I only have disk 0. I check the box of which ones I want to do. I'd click OK, and it would convert the basic disk to a dynamic disk. But here's the thing. Make sure that you definitely want to do it. Make sure that you don't need for this disk to be backward compatible with some older operating system. And if you're thinking to yourself, well, why would I need that? I mean, we have Windows Server 2012 installed. Keep in mind that a hard disk, right, an actual physical hard disk could be moved from one computer to another, especially if you have hot swappable disks, if you're moving disks from one computer over to another one. And if you don't know what hot swappable means, it means that you can literally take them out while the system is hot, meaning while it's running. So if you were to move these disks to another computer, you need to make sure it's not going to need to support older operating systems. And when I say older, it would have to be pretty much pre-Windows 2000 operating systems. And the reason I say you need to be certain of this is because once you go to a dynamic disk, there's no easy way to convert back to a basic disk. You can do it, but you have to erase everything. It has to be a blank disk, and then it can be converted back to a basic disk. Now, speaking of moving disks from one computer to another, this is another advantage to using dynamic disks. Okay, there's a number of advantages actually, and they have to do with like the number of partitions you can have, and they have to do with the size of the partitions and things like that. But one other advantage is that it will actually allocate a very small piece of the disk itself to maintain its own configuration information. As a basic disk, this configuration is being maintained by the operating system. And if you were to take this disk and move it over to another computer, that other computer may not understand the configuration, especially if this disk participated in one of those RAID volumes. All right, so if this disk was participating in RAID 0, RAID 1, or RAID 5, so this was just one of a certain number of disks, the new system would not understand necessarily what to do with the disk when it got over there. A dynamic disk, however, if you take it out of one computer and you move it over to another, the new operating system will ask the disk, right? It actually has the configuration on the disk itself. It'll ask, it'll say, okay, so how are you configured and what are each of these volumes that I see that you have set up for yourself? And then that information will be shared with the operating system, and the operating system will know what to do with that disk. And it will also know to tell you if you brought over a partial set, right? If some of the RAID volume was brought over but not all of it, it'll tell you that. So that's pretty much how you manage local storage. The only other real quick comment that I will mention to you when it comes to local storage is I will mention that we also have something called virtual hard disks. Okay, so we have virtual storage, and I'm just going to kind of leave it at that because virtual storage has to do with using virtual machines, or we'll even just say virtualization as a whole. And there is another lesson where we talk about Hyper-V and virtualization, where we will talk in more detail about those virtual hard disks. And so that does bring us to the end of another lesson where we've now seen how to manage storage as it is local to our individual servers. And as I mentioned a moment ago, we will go ahead and get to virtual storage in the virtualization lesson. So make sure to stay tuned for that. But speaking of another lesson, I'll see you in the next lesson.